Okay, so we're going to finish up this unit by doing the last of the operations we can do with rational expressions. That's adding and subtracting. So if you remember back to when you first learned about fractions and working with fractions, adding and subtracting fractions turned out to be a little bit harder. Because remember, you had to find a common denominator between the two or three fractions you're adding or subtracting before you could actually start combining them. Not the case of multiplying and dividing, you just do a straight multiplication or multiplication by the reciprocal in that case, but a little bit trickier with adding and subtracting fractions. So remember, you always need a common denominator when you're adding and subtracting fractions, and you always want it to be the lowest common denominator. So let's just say you're looking at doing 3 over 10 plus 4 over 25. Well, you got to make sure you find the lowest common denominator between 10 and 25, because what a lot of people will do is just say, okay, 10 times 25 is 250, and use a common denominator of 250. Which is all well and good, but it makes your question a lot more complicated. That isn't such a big deal when you're dealing with numbers because, again, you usually are pretty good with numbers to be able to get your new numerators. Eventually when we're dealing with variable expressions here, using something that's not the lowest common denominator will create a lot of problems. So we want to try and use the lowest common denominator. So in this case, we look for what's common between 10 and 25. Well, the easiest way to do that is to break the denominators down into prime numbers. So 10 is 5 times 2. And 25 is 5 times 5. And what you then want to do is make sure that you include everything you need to create the common denominator. So for example, the 10 for common denominator is going to have a 5 and a 2. Okay, and if you look at this for the 25, there's 2 5s here, but there's already 1 5 over here, so we actually only need 1 5 from this to create the common denominator. So our common denominator is going to be 5 times 2 times 5, which is 50, and you can see that 50 is a much smaller common denominator than using 250. So you want to make sure you use the lowest common denominator. And in that particular case, remember, what you would have to do then is you would have to then adjust the numerator accordingly. So for example, from this fraction was originally had a numerator of 3, the denominator was 10, now it's 50, so the numerator needs to be multiplied by 5. Okay, when you're looking at the next piece right here, the next fraction, the original numerator was 4, the denominator was 25, now the denominator is 50, so how do you get from 25 to 50? You multiply by 2, which means the numerator gets multiplied by 2 as well. So what you wind up with in the end is 15 plus 8 all over 50, okay, which then simplifies into 23 over 50. Okay, the next thing to remember, and hopefully this isn't coming just too much surprise, order of operations is important. So remember, brackets and exponents, multiplication, division come before adding and subtracting. So that comes up, remember to keep your order of operations in mind. Okay, so with all this in mind, I want to talk more about this lowest common denominator business that we kind of started up here, and see how it applies to using rational expressions. So we're just going to do a whole bunch of different pairs, or in some cases, trios of fractions, and see what their lowest common denominator would be. And you can see in this case, they aren't just numbers, they're variable expressions. So you'll notice here that for each lowest common denominator, I've sort of drawn a little bag or a suitcase. And that's kind of the analogy I like to use when you're trying to find a common denominator, is only pack what you need to make a lowest common denominator, don't overpack. So for example, for this first one right here, again, we're only looking at the denominators here because it doesn't matter if we're adding or subtracting them, we're just trying to find what the lowest common denominator is. So between a denominator of 3x plus 5 and 6x minus 1, okay, to find the lowest common denominator, again, let's just make sure that every fraction has what it needs for the lowest common denominator and nothing more. So you look at the first fraction, always pack that first. So we need a 3x plus 5. So we need a 3x plus 5 as part of our lowest common denominator. Okay, so that's all packed. So now we take a look at the second fraction and say, okay, he needs a 6x minus 1. There's not already a 6x minus 1 in here, so we pack that as well. So now everybody's happy. You can see that each fraction has exactly what it needs in the lowest common denominator bag or suitcase, whatever you want to call it. So the lowest common denominator in this case is simply going to be 3x plus 5 times 6x minus 1. Okay, and on the surface that doesn't seem too bad, but we just got to make sure, again, the idea that we don't overpack, that we don't put too many things in the lowest common denominator. And we'll see why when we start doing some examples later, but again, for now it's important to only pack what we need. So now, take a look at this second one right here again. Let's look at our denominators. So the first one needs a 3x minus 7, so we're going to pack that. Okay, and it needs a 2x plus 1. Okay, so now this first fraction has everything it needs for the lowest common denominator. Now let's move on to the second one. It has it needs, an x minus 6. There isn't one already here, so we're going to pack it. Okay, and it needs a 3x minus 7. However, before we put a 3x minus 7 in here, we recognize that we already actually have one right here. So they can actually share this 3x minus 7, just like on the previous example when the 10 and the 25 could share a factor of 5. So we don't need to pack another 3x minus 7. You already have one right here. So lowest common denominator in this case, instead of being 4 binomials, it's only 3. So 3x minus 7, 2x plus 1, x minus 6. Okay, so the next couple ones are a little bit tricky. I'd like you to try them on your own first, just see how far you can get. And again, we're going to take them up together, but I want you to see if you can apply what you've seen so far and try and create lowest common denominators for C and D. And if you want to try E right now, you can, but you can start with this C and D. Okay, so just taking up C. So we've got 12, 4x minus 5, and then 6, 4x minus 5 all squared. So again, start with the first fraction there. So this one needs a 12, and it needs a 4x minus 5. Done. So now let's take a look at the second one. It needs a 6 and a 4x minus 5 all squared. So let's start with the 6th. Now, we don't need to pack a 6 because there's already a 12 here, and 6 already goes into 12 evenly. So there's no need to add anything else there, just because that 6 is already covered by being a factor of that 12. So that's already covered. The next thing it needs is it needs 4x minus 5 all squared, which you remember is just 2 4x minus 5s. Now, do we need to pack both of them? No, because the first fraction already packed 1 4x minus 5 for our little lowest common denominator here. So we only need one additional 4x minus 5 to satisfy the second fraction. So again, let's just check. We have 12 times 4x minus 5. We have 6, which goes into 12, so 6 is covered. We need 2 4x minus 5s, and they're both in here in the lowest common denominator. So your lowest common denominator here is going to be 12, and then 4x minus 5 all squared. For D, with the denominators, you have to make sure they're all factored first, so hopefully you started by factoring them. So the first one factors in 2x minus 5 times 2x minus 5, and the other one factors into 4 times 2x squared plus x minus 15, which factors further into 4 times 2x minus 5 times x plus 3. So for your lowest common denominator, for the first one you need 2x minus 5s, so let's pack those. Okay, so those are covered. So now, for the second one we need a 4, so let's put that 4 into here. It says we need 2x minus 5. We already have 2 of them in fact, so that one's already covered. And we need an x plus 3. So putting all those together, we have a lowest common denominator of 4, 2x minus 5 all squared for each of those 2x minus 5s, and then an x plus 3. Okay, so last but not least, if you haven't already done E, give it a try now. So now we have 3 fractions and we want to find the lowest common denominator. So again, start by doing the factoring and see if you can find the lowest common denominator for all 3. Okay, so you can check your lowest common denominator there. So piece by piece, so looking for the first one, we're going to need a 3x plus 2 and a 2x minus 1 from the first fraction. As we look at the second one, we need a 5x plus 7, which isn't already packed, so we'll pack that. Sorry, I'll put that in green so it matches the other fraction here. 5x plus 7. It also says we need a 2x minus 1, but I already have one packed here, so that one's already covered. And then for the third one, we need 3x plus 2 and 3x plus 2. One of them's already packed, so we need a second one. So put all those together, your common denominator is going to be 3x plus 2 all squared, because there's 2 of those there, 2x minus 1, and 5x plus 7. Okay, so with that in mind, now we've practiced finding lowest common denominators, let's think about how we add or subtract fractions, more specifically ones with rational variable expressions in them. So first thing you want to do, just like when you're multiplying and dividing, is make sure everything is fully factored, including all common factors, including -1 common factors that are there as well. Once it's factored, you put everything down in lowest terms. So if there's any simplifying you can do within each fraction, make sure you can do so. And at that point, we then need to do is find the lowest common denominator, using the same tools we just did on the previous slide. Once you find the lowest common denominator, remember that when you start adding fractions, you can't just change the denominator just because you want to. To adjust for it, you have to change the numerator accordingly as well by multiplying it by whatever the denominator is multiplied by to get to the LCD. Okay, so we'll see that in action once we start getting to that point. So once we have the new numerator, we can then simplify as much as we possibly can, and then of course see if it can be simplified any further. Okay, so again, if you follow these steps, it usually limits your mistakes. So looking at this first one here, we have 3 over xy minus 4 over y squared. So everything's already a factor in here. There's no simplifying that can be done within each fraction. So what you're looking to do right now is to try and find your lowest common denominator. Okay, so let's take it piece by piece. From your first fraction here, there's an xy, so we pack an x and a y. For the second fraction here, we need a y squared, which is really just, again, y times y. We already have one y here, so we're going to add a second y, so now there's a y squared in the denominator as well. So your lowest common denominator is going to be xy squared. Okay, so I'm going to write that in here. So that's a very good start. So we have our lowest common denominator. Now we need to determine an expression for the new numerator. So the common mistake that people are going to make, that I see a lot, people are just going to write the new numerator as 3 minus 4, which of course, as you know, is not true, because this 3 came from having a denominator of xy. This 4 came from having a denominator of y squared, but now the denominator is completely different. So we need to adjust our numerators accordingly. So for example, looking at this first fraction here, let's say we have our 3. Okay, our original denominator was xy. Now the denominator is xy squared. So we had to multiply this by y to get y squared in the denominator. So you have to multiply the numerator by y as well. Okay, so now let's keep going. Minus. Now we have 4. The original denominator was y squared. Now the denominator is xy squared. So the only difference is this was multiplied by an x, the denominator was. So the numerator needs to get multiplied by x as well. So we have 4 and then times x. So what we wind up with is 3y minus 4x over xy squared. Okay, and that cannot be simplified any further. Nothing was canceled. There's no need to worry about any restrictions. This is it. We're now done. Okay, so the first one hopefully wasn't too bad. Let's try and take a look at some that would be a bit more typical. So we have 5 over a plus 1 plus 13 over a minus 3. So again, everything's factored. There's nothing to simplify within each fraction, so it's just a matter of finding a lowest common denominator. So again, I recommend you just make a little box for your lowest common denominator to make sure you don't forget anything at all. So for the first fraction, we need an a plus 1. From the second one, we need an a minus 3. So our lowest common denominator is simply going to be a plus 1 times a minus 3. Okay, so now we have that. We have to find a new expression for the numerator. So remember, we had a 5, we had a 13. You have to make sure we multiply by the right things to create our new numerator. So for example, looking at this 5, the original numerator was a plus 1. So the new denominator is a plus 1, a minus 3. Okay, so this needs to get multiplied by a minus 3 in order to create a new expression for my numerator. The 13 needs to get multiplied by a plus 1, because again, the original denominator is a minus 3. Now it's this. The only difference is that a plus 1. So 13 needs to get multiplied by a plus 1. Okay, so that's a very good start. All that's really left from here is to just expand and simplify the numerator. So 5a minus 15 plus 13a plus 13, which simplifies into 18a minus 2 over a plus 1, a minus 3, and we're done. Okay, so we'll do one more before this video ends. So the only difference with this one is you'll see now this denominator is not factored, so please make sure it is factored before you can do anything else. Okay, so it's a difference of squares that factors into m minus 3, m plus 3. Okay, so I want you to take a second to find the lowest common denominator and then put it down here in your next line. Okay, so hopefully you recognize your common denominator as m minus 3, m plus 3. So you pack both of those for the first fraction. But you see the second one needs an m plus 3, but there's one already packed, so there's no need to add anything else. So when you're adjusting your numerator, okay, so again, the 10 already has the m minus 3, m plus 3. Doesn't need to change at all because the denominator has stayed the same. For the 5, however, the denominator was only m plus 3. Now it's m plus 3, m minus 3. So the 5 needs to get multiplied by m minus 3. Okay, so at this point now, just simplify it. So you have 10 minus 5m plus 15. So you get negative 5m plus 25 over m minus 3, m plus 3. Again, nothing canceled here, so there's no need to worry about any restrictions. Okay, so once you have the lowest common denominator, the big step that everyone forgets is, again, making sure the numerator has been adjusted accordingly. Okay, so here's another one I'd like you to try. We're going to finish this in the next video, but start by factoring the denominators so we have a start when we get to this part 2. Okay, we'll see you over there.